Good afternoon, class. Um, like you, I'm also locked down here in Dubai, in the house of my daughter and son-in-law, and preparing this lecture, giving this lecture from Dubai. So we will be using my PowerPoint presentation. So I am going to share it now. Okay. Okay. My lecture will be divided into three parts. We have here number one, optics of vision. Number two is receptor and neural function of the retina, and then central neural physiology. So I will be cutting this video presentation into three parts. So after every presentation, at least you could rest, you could walk around and exercise. Okay, so let's now start with the optics of vision. Optics of vision is actually the physics of how we see things. Okay? When you see an object, it emits light rays. Okay, this one. So, if, for example, you have an object here, it emits rays, and when it meets an obstacle like a glass here, if it's a straight glass perpendicular to the light rays, these light rays from an object will just um, slow down in its speed. So this is a faster speed and slower speed. But if you put a glass which is obliquely placed here, it will refract or bend the light rays like so. Okay? So when you refract light rays through convex spherical lenses like this one, first the light rays will go straight there, and then at the point where it meets the spherical lens, it will bend, but it will converge into a focus point here. And this distance between the lens and your focus would be called your focal length. Okay, but if you make light rays go through concave spherical lens like this, instead of converging, the light rays will diverge like so. Okay? If you compare a spherical and cylindrical lens, if you use a spherical lens, the light rays will converge in a focus point, while in using a cylindrical lens, the focus will fall in a focal line, into a focal line there. Okay, so this is like using a magnifying glass wherein you keep on moving it. If this is a light source like the sun, keep on moving it, it will focus into a focal point. And this is like using test tube filled with water. So the vision is a line. It is not a focal point, it's a focal line. Okay. These are placed here to show you how one sees an object. So this is one object. This is one object here. Okay, and this is the one object there. And okay, this is one object there coming from here, and it will focus in a focal line. Okay, if you use a cylindrical lens. Okay, this reference, remember this reference because this is what happens when you have astigmatism. So let's go to this later when we discuss astigmatism. Okay, if you have three different lenses of three different thickness, you will note that the thicker it is, the nearer it converges the light, the nearer the focal point there. So here you have a very far object. It passes through the lens, a thin lens. It converges here. Here you have a very near point source or near object. This should, if this is not, if it, like this one, if it is not, it doesn't pass through a thickened object, it converges at a very far point, while the thicker lens converges the light rays into a nearer point here. Okay, so far point, near focus, near point, it should be far focus, but it focuses here because the lens is thicker. Okay. In the formation of an image, so you have now this focal line here. You are seeing an object through the focal line there. And whenever you see an image, it is always inverted in the retina. So this is the retina. So this is the object there, the object here, object. Okay. And when it registers in the retina, it is upside down. But when the retina sends messages or neural messages to the brain, it becomes upright because this is how the brain interprets it. So let's now go to the strength of the lens. The lens, if you have an object from far distance, if this is the flattened lens, it converges at 1 meter. Okay, you thicken the lens to a certain point, it converges at 0.5 meter. Okay, thicken it more, and it converges in a nearer focus point. Okay, so this is what you call the diopter. Okay, so as you increase the lens, the thickness of the lens, you increase the diopter of the lens or the strength of the lens. So let's now see the eye. The eye as a camera has the aperture, the pupil, the lens system composed of this whole thing, cornea, aqueous humor, lens, vitreous humor. Okay? And then the film or the image is registered in the retina, which is the film system of the camera. So this whole thing, the eye, has a total refractive power of 59 diopters. Okay, so it is it has a very strong refractive power. Okay, so it has an aperture system, the pupil. Retina corresponds to the film. The lens is composed of 4 refractive interfaces, which is what? Number 1 is between air and the anterior surface of the cornea. Number 2 is between the posterior surface of the cornea and the aqueous humor. Number 3 is the aqueous humor in the anterior surface of the lens of the eye. And then posterior surface of the lens in the vitreous humor. Such, okay? 1, 2, 3, 4. Okay. The eye is called a reduced eye because it is considered as one single lens. It exists as a single refractive surface. Its central point is 17 millimeters in front of the retina, and it has a total refractive power of 59 diopters, as seen in the figure a while ago. 2/3 of these 59 diopters of refractive power of the eye is provided by the anterior surface of the cornea. The refractive power of the internal lens of the eye is only 20 diopters, or 1/3 of the total refractive power of the eye. But in response to nervous signals from the brain, lens curvature can be increased markedly to increase its diopter, and it is called accommodation. When the image is first registered in the retina, it is reversed and inverted, but the mind perceives the objects in the upright position, despite this upside down orientation on the retina, because the brain is trained to consider an inverted image as normal. How is the mechanism of accommodation achieved? Okay. In children, the refractive power of the lens can increase from 20 diopters to about 34 diopters, which gives an accommodation power of 14 diopters. To make this accommodation, the shape of the lens is changed from that of a moderately convex lens to that of a very convex lens. The lens is composed of a strong elastic capsule filled with viscous, proteinaceous, but transparent fluid. When the lens is in a relaxed state with no tension on its capsule, it assumes an almost spherical shape, owing mainly to the elastic retraction of the lens capsule. Okay. So this is a rear lens. Okay. It is more or less flattened. Okay. About four, you have suspensory ligaments and ciliary muscles around it. Okay. About 70 suspensory ligaments attach radially around the lens, pulling the lens edges toward the outer circle of the eyeball. This makes it constantly tensed by their attachment at the anterior border of the choroid and retina, thus causing the lens to remain relatively flat. Lateral attachment of the lens ligaments to the eyeball is the ciliary muscle, composed of two separate sets of smooth muscle fibers, meridional fibers and circular fibers. When both muscles contract, they relax the ligaments tension on the lens, making the lens assume a more spherical shape like that of a balloon because of the natural elasticity of the lens capsule. Okay. Okay. So this is your suspensory ligament attached here to your lens. And it is always taut or tense, making this lens tense and flatter. But the circular fibers of this so this is your ciliary muscles. This you have the circular fibers and the meridional fibers. When both contract, they release tension. When they both contract, this relaxes your ligaments, so your lens becomes less tense and more and more or thicker. It becomes thicker and rounder. Okay, so it now increases the diopter power. It now makes your eye accommodate. So okay, accommodation is also controlled by parasympathetic nerves. Okay, the ciliary muscle is controlled by parasympathetic nerve signals, and this is transmitted to the eye through the third cranial nerve. The stimulation of the parasympathetic nerves contract both sets of ciliary muscle fibers, which relaxes the lens ligaments. Lens become thicker, and its refractive power is increased. As a distant object moves toward the eye, the number of parasympathetic impulses impinging on the ciliary muscles progressively increase for the eye to keep the object constantly in focus. So as an object comes near your eye, the lens becomes thicker and thicker through the parasympathetic stimulation, so that this object coming near your eye becomes more focused through accommodation of your lens. What is presbyopia? When, as a person grows older, there is loss of accommodation by the lens. The lens grow larger and thicker and become less elastic due to progressive denaturation of the lens proteins. Therefore, the ability of the lens to change shape decreases with age. The power of accommodation decreases from about 14 diopters in a child to less than 2 diopters at age 45 to 50 years, and 0 diopters at age 70 years. When the lens become almost totally non-accommodating, you call it presbyopia. Okay, presbyopia. The eyes can no longer accommodate for both near and far vision, and to be able to see clearly both in the distance and nearby, you wear bifocal glasses, okay, like this one, for far distance, and the lower segment for near seeing, or e.g., and for example, for reading. Yes, class, I'm already progressing to presbyopia. Okay. What is the effect of pupillary aperture? What is the effects of aperture? The bigger the pupil aperture is, okay, the lesser you are able to focus on the retina. The smaller the aperture, the greater is the distance of a focal point. So you have focal point traveling from here to here, okay? While in a bigger aperture, the focal point is only up to this part. Okay, so any um, any object found here or there, it is unclear. While in smaller pupil, uh, it is from here to here. Focus is from here to here. Okay, so this means that with a smaller pupillary aperture, you have a greater depth of focus. Okay, so this pupillary diameter is brought about by the function of the iris. It increases the amount of light that enters the eye during darkness, and it decreases the amount of light that enters the eye in daylight. The quantity of light entering the eye can change about 30-fold as a result of changes in pupillary aperture. So the depth of focus of the lens system increases with decreasing pupillary aperture. Okay. So let's now see um, how accommodation impacts vision. Okay. For a normal eye, we call it emetropia. Okay. Um, it focuses objects at the retina, so there is clear vision. This is brought about by a strong lens system, which accommodates any object that is seen in the eye of different distances. Okay, hyperopia is having a small eyeball, could be due to a small eyeball or a very weak lens system. So it cannot accommodate some objects within a certain distance so that the focus is beyond the eyeball or beyond the retina, so you don't see clearly. Okay. Myopia is the problem here is that you have a very big eyeball so that the focus is in front of very far in front of the retina, or you have a very strong lens system so that it bends the light so strongly, the focus, it converges it at a distance from the retina, so it's still blurred even if the even if the object is very near. Okay. So we have the errors of refraction, emetropia, normal vision with the use of accommodation for seeing distant and near objects. Okay. Hyperopia or farsightedness, usually due to either an eyeball that is too short or a lens system that is too weak. By using the mechanism of accommodation, a far-sighted person can focus distant objects on the retina. Okay. In myopia or nearsightedness, here, myopia, uh, this is hyperopia, myopia. Okay. In myopia or nearsightedness, this is usually due to a very long eyeball or from too much refractive power in the lens system of the eye. There is no mechanism to decrease the strength of the lens. You cannot decrease it. Okay. If it's already very thick, you cannot decrease the thickness. You can only thicken a thin lens, okay, thicken. But if it's already naturally thick, you cannot make it thinner. Okay. The person that can use the mechanism of accommodation to keep the image focus clearly only for near vision. Okay, so um, the nearer for a myopic person, the nearer the object goes into your near your eye, the more focus it is in the retina. The farther it is, the less focus it is in the retina. So for hyperopia, you can see it is farsightedness, so you can see far objects clearer. For myopic people, you can see near objects clearer or in focus. So how do we correct errors of refraction or EOR? So if you have a very long eyeball and the object falls way in front of the retina, so it's out of focus, you use concave lenses to diverge the light rays first, and then it then focuses on the retina after diverging it first. Diverge, diverge, and then converge at the retina. If your eye is hyperopic or small, or the lens system is weak, you use convex lens to converge the lens, sorry, to converge the light rays and to converge it more so that it doesn't fall, the focus doesn't fall behind the retina and falls exactly on the retina, so there is clear vision. Yeah, yeah. Myopia, refractive surface of the eye, neutralized by placing concave spherical lens. Hyperopia, very weak lens system. So you use convex lens. The strength of the concave or convex lens needed for clear vision is determined by trial and error. So whenever you go to an optometrist or ophthalmologist, they try several glasses in front of you, right? And they first try a strong lens and then a stronger lens or weaker lens until the one that gives the best visual acuity is found. That's how you find the grade of your glasses. That's how you find the correction of your EOR. Okay. Astigmatism. Astigmatism is actually due to a refractive error that is because of abnormal or unequal curvature of the cornea. The focal points the focal points fall in different planes in the retina because of this, and each of the two, so you create two planes with different degree of accommodation. Without the aid of glasses, a person with astigmatism never sees in sharp focus. So, take care. So this is your lens system. It it creates two planes of focus. This is clear. This is clear at this point, but this is unclear. This is clear at this point, but this is unclear. So you have two planes of focus. Okay. You correct astigmatism by using cylindrical lens. Okay. One may consider an astigmatic eye as having a lens system made up of two cylindrical lenses of different strengths and placed at right angles to each other. Remember the figure I showed you at the beginning with two cylindrical lenses at right angles to each other. So to correct the EOR in astigmatism, the usual procedure is to find a spherical lens by trial and error. Okay, a spherical lens, you use spherical lens, and then it corrects the focus in one of the two planes of the astigmatic lens. And then an additional cylindrical lens is used to correct the remaining error in the remaining plane. That's how you correct astigmatism. Okay, so this is how you correct astigmatism. The optometrist will let you see this chart and they'll ask you which part is clear and which part is an out of focus. Uh, there are other abnormalities that needs to be corrected. Okay, so in some abnormalities, you can use contact lenses which could fit snugly against the anterior surface of the cornea. The contact lens substitute for the cornea's usual refraction. It's important in people whose eye refractive errors are caused by using the contact lens is important in people whose eye refractive errors are caused by an abnormally shaped, odd-shaped cornea or bulging cornea, a condition called keratoconus. Okay. The other advantages of using contact lenses is that the contact lens turns with the eye and gives a broader field of clear vision than glasses do. The contact lens has little effect on the size of the object that the person sees, whereas lenses placed 1 cm or so in front of the eye, like eyeglasses, affect the size of the image in addition to correcting the focus. Okay. What are the other abnormalities that could occur in the eye? Cataracts. These are cloudy or opaque areas in the lens due to protein denaturation. Okay. As one grows older, you expose your eyes to the sun. Okay. The sun has UV lights, which denature the proteins in the lenses until eventually it becomes opaque. This is likened to an egg, okay? The egg, you have the clear portion of the egg, which is the egg white, okay? You expose this raw egg on top of a car, okay? On the car, there would be the sun shining on it. Later on, the egg is cooked, okay? The protein of the egg, the clear protein of the clear egg white becomes denatured and becomes white. So that's what happens with cataract formation. Okay. Cataracts could also occur when you expose your eye your eyes to laser beams. Okay, so this is one disadvantage of being a dermatologist with all the laser machines. So you wear special goggles. You will note that your dermatologist and you use special goggles to cover your eyes so that the laser beams that come out from the machine doesn't denature the lens of your eye. Okay? These cataracts, of course, replaced with artificial lenses through surgery. Okay. What is visual acuity? Visual acuity is actually seeing 2 points at 2 points in the retina and not as 1 point. The fovea is around 2 micrometers in diameter, so that point should be seen beyond this. If the points are less than 2 micrometers in micrometers, then these 2 points will be seen as one. So if you put these 2 points near each other, this will no longer be seen as 2 points but as 1 point. Okay. So visual acuity is actually seeing 2 points as 2 points and not as 1 point. Okay. So based on this, visual acuity is okay. So based on the average diameter of the cones in the fovea, which is 1.5 micrometers, a person can normally distinguish two separate points if their centers lie up to 2 micrometers apart on the retina. Normal visual acuity of the human eye is also when light rays from two separate points strike the eye with an angle of at least 25 seconds between them. Here. They you can usually be recognized as 2 points instead of one. The clinical method for assessing visual acuity is, you're familiar with this, a chart for testing eyes consisting of letters of different sizes is placed 20 feet away from you, from the person being tested. And if the person can see well the letters of a size at 20 feet, the person is said to have 20/20 vision, which is normal. But if the person can see only the letters that should be seen at 200 feet, the person is said to have 20/200, 20/200 vision. Okay. There is also, how do we perceive distance? Okay, or stereopsis. Okay, it depends on the size of the image. Okay, and it also depends on where it falls on the retina. So a distant object falls on this side of the retina, while a nearer object falls on this part of the retina. This will be discussed in more detail when we go to the central neural physiology part 3. Okay, but it is good to know for now that you see you perceive distances by the places where the objects fall in the retina. Okay. Let's now go to the fluid system of the eye. The fluids, you have to have fluids in the eye so to maintain its turgidity, okay? Turgid, to become turgid, okay? The ciliary body produces fluids which circulate in the eye, here. And whatever washes off, or washes off, sorry, it washes off or cleans the eye, and whatever debris or whatever is found in the eye, this is cleaned and flushed through the spaces of fontana and canal of Schlemm, okay, and then drained by the villi later. Okay. Okay, so here the ciliary process produces aqueous humor. Okay, and this aqueous humor or fluid of the eye, which is produced, passes through the pupil and drained here in the canal of Schlemm and collected by aqueous veins or the blood veins. Okay. There is a normal intraocular pressure of the eye, which is 50 millimeter mercury or 12 to 20 millimeter mercury. So beyond 20 millimeter mercury, you have the pressure is means that the pressure inside the eye is increased, meaning there is a failure of drainage here. Okay, so if there's a failure of drainage, fluid will accumulate, and this increases the IOP, and this could, okay, in IOP into this part, and this could impinge on the optic nerve, on the retina, and this is what you call glaucoma. Okay, so glaucoma could impinge on your optic nerve, which causes blindness eventually. Okay, so you have to um, you have to improve the drainage by giving medications, drops, which will remove the debris or which will increase the drainage of the fluid. Okay. Okay, so I think this ends our first part. I will upload it first, and then I'll see you later. Go and study this slide, and then exercise, and then come back for the second part.